Hey folks, Knox with IT Inspired here. Wanted to talk to you today about something that may be a little big or a little complicated. If you're a little lightweight on the networking side of things, then deploying a virtualized infrastructure like Hyper-V, when you get to the networking aspect of it, it may seem a little scary or a little shaky. It's one of those things that requires a tremendous amount of planning to get it done right up front. The actual implementation, the actual clicking and typing of it will take no more than 5 minutes. But you should spend plenty of time planning for it because it is very, very important and can have large impacts on your environment if you have to go back and change it. So as you can see, I've got Microsoft Paint up here, so you know you're in for a doozy. Without further ado, let's get started talking about how to plan and design and prepare for networking in a Hyper-V environment. All right, so let's get to drawing. Let's see. I'm going to draw a server here. Yep, that's about as bad as it can get, but that's the best. That's what we got to deal with. And let me get back to full screen. Here we go. And let's draw a switch down here. Because that's going to be a big part of it too. This is going to be our switch, and I'll walk you through what to do about if this is Juniper, Cisco, Force10. And the port that we're going to use on this switch for demonstration purposes, we're just going to use the very first port. So let's get my mouse down here. All right, let's just call this port 1.1. All right, 1.1, and a second port we'll use. All right, we'll call this 1/2. And up here on my physical host, we're going to say we have two NICs. All right, we're going to call it NIC 1 and NIC 2. That's going to be their names. Okay, so how the virtualization stack works in Hyper-V, when you go to actually install Hyper-V, before you even spin up VMs on this, you need to have the network in place so those VMs can attach to it. I mean, I guess technically you can build VMs. It'll let you go through the wizard. It won't fuss at you about it. But you should absolutely have this part done beforehand just so you can streamline the process and make it easy to go. All right, so for this environment, I'm going to say we have a management network, which is how I'm going to access this Hyper-V host. It's going to be VLAN 10, and that'll be a subnet of 10.10.10.0/24. All right, that's really ugly, but it's getting the point across. And for my VMs, I want my VMs to communicate on a different VLAN. I want them to be on VLAN 50. All right, and you can kind of guess what the theme is here: 10.10.50.0/24. So up here, our VMs are going to live on VLAN 50, and this machine, however, is going to communicate on VLAN 10. It's going to be managed over VLAN 10. So it depends on how you want to do this first. This is a big decision right off the bat. Do we want this host to share the traffic going across the physical wire as a trunk port, or do we want them to be separate? If we want them to be separate, that's pretty easy. We can have VLAN 10 just connected right here, or we can and then have VLAN 50 connected right here. Do you see where this might be an issue right off the bat? Junior admin comes along, changes the access port rules here on gig 1, 2, and boom, down goes VLAN 50. Down go these VMs. There's no connectivity. We can still get to the management port here, and we'd start troubleshooting like, oh, what's going on with my VMs? Not a big deal that we can get to them, but we wouldn't be able to find the answers here because it was misconfigured on the actual physical switch. The other option that we could have is maybe we can bond these two physical NICs together as one NIC, and then trunk the traffic going across, where we tag the VLANs as it goes out the VM and into the physical switch. I would say that would be the better way to do it. It may be different depending on your environment. You may have rules. You may be a cloud provider where your tenants have to be on a separate physical network than your management traffic. That makes sense too. But basically, the way this begins, right off the bat, the first decision you have to make is how this is going to be laid out. For this environment, I'm actually well, we're not going to really walk through anything, but I'm just going to say let's just plan on bonding these two together and then building a trunk port that goes across. All right. So once we get into Hyper-V, the very first thing we do is we create a virtual switch. And that is going to live right here. And there's going to be all these virtual switch ports that you'll never see. You don't actually configure the switch ports themselves. You configure the VM. And when you build this virtual switch, it asks you which physical NIC do you want to bond this virtual switch to, assuming you go with an external switch. In fact, let's back up a little bit and talk about the 3 different types of virtual switches. So excuse me about that. The first type of virtual switch is called an external virtual switch. And what that means is that you're going to bond this virtual switch to a physical NIC so that traffic can go from a VM into this virtual switch, out the physical NIC and into your physical network down here where the switches live. So that is when you need these VMs to be able to talk to either the rest of your physical network or even the external internet. You're going to want to use an external virtual switch. There is also called an internal virtual switch, where you don't pick a physical NIC to bond it to. The VMs can communicate with each other on this host as well as with the host itself, but they will not be able to exit the physical NIC. And the last is called a private virtual switch, which is where the VMs can communicate only with each other. Even the host itself cannot see what the VMs are talking about. There's no communication between the physical host and the VMs themselves. So for the most part, we're going to be talking about an external virtual switch today. And like I was saying, when we build this new virtual switch, the first question we're going to have to answer is which physical NIC do we want to bond it to? Now, if we're actually going to be pairing these two physical NICs, we're going to build a different kind of. It's going to be an external switch, but it's going to be done through PowerShell. We'll go over that in a second. But for simplicity's sake, let's just say I chose to have this virtual switch connected to the physical NIC 1. Okay, so I'm going to have the management traffic come in through here on VLAN 10. I'm going to have the VM traffic coming out of here and back up or whatever on VLAN 50. Okay, so if I grab the little text editor and let's just start typing. Maybe if you're in a Cisco environment, let me expand this text box really big here. If you're in a Cisco environment, you're going to do enable and then config T, and let's go to interface gig 1.1, and we're going to do switch port trunk encapsulation .1Q. That's the first command we have to do, so we let it know what kind of trunk it's going to be. Then we're going to do switch port mode trunk. And if we want this to be the native VLAN, so that way we don't have to do any tagging on VLAN 10, it's switch port trunk native VLAN 10 and switch port trunk allowed VLAN 50 for the VMs. So now the traffic's going to exit this Cisco port on 1.1. If it comes in untagged, then it's going to be VLAN 10. And if it comes in tagged, we're going to set the VMs to tag the 50 in a later example. It'll know to be broadcast out VLAN 50. You can see this is a trunk port, though. That's how this magic works. If you're in a Juniper environment, it's going to be something like set VLANs. Let's call it management VLAN ID 10 and set VLANs VMs VLAN ID 50. And then, of course, set interfaces gig 1.1, even though that's not how Juniper is going to do it. They're going to do 0.0 because it's Juniper. Unit 0 family Ethernet switching VLAN members MGMT. Got to do our braces, right? MGMT VMs followed immediately by, for simplicity's sake, because that's a lot of typing, native VLAN ID MGMT. And then lastly, if you're in HP, Aruba, or Force 10, you're going to create your VLANs, of course, and then, do enable config T. If I can type today, there we go. We're going to create VLAN 10 and VLAN 50, and then interface VLAN 10, and we're going to say untagged gig 11, and then go to interface VLAN 50, tagged gig 11. So that's going to be the switch port config that we do depending on which brand of switches we have. All right. So the last thing that we really need to talk about here with this host, this is another very important thing. When I chose to make this when I chose this NIC1 to be the physical adapter, what that's going to do when you actually bring up your adapters in the future, you're going to be like, wait, what's going on here? My NIC1 has no config on it. Nothing is checked. That's because this creates a virtual adapter up here. Let's get off of... Ooh. Sorry about making this configs go away. It's going to make a virtual adapter called vEthernet, and that's where we assign our IP addresses to. It will then go into the switch and then out this. So that vEthernet is going to be what we configure our host IP addresses on. Okay, we've talked about this a lot. I think it's time to actually dive into it and show you what it looks like in process. I'm going to bring up my lab environment here. Now this one is already configured, but like I said, the planning and design aspect of it takes a whole lot longer than the actual configuration. As you saw, I typed out commands on 3 different brands of switches in about maybe a couple minutes. So let's actually show you how quickly we can configure the virtual switch itself. Okay, so here we are in Hyper-V Virtual Manager, and like I said, I've already built this out. But one of the first things you're going to do if there's nothing here, if you've configured nothing, is you're going to come over here to the right and click on Virtual Switch Manager. Okay, very cool. I'm going to zoom in a little bit so that we can follow this a little closer. Maybe not. Okay, we won't zoom in. That's okay. So remember those 3 virtual switches? This is the first question we're presented with, is what type of virtual switch do you want to create? We've got external, which is the one where we want to go to the physical network. Internal, which has reminders for VMs to communicate to each other as well as the host. And private, which is just for VMs to communicate to each other. I'm going to choose external, create virtual switch. Okay, first thing you want to do is give it a name. We're going to call this maybe external 2 or something. And this is where we choose which physical NIC do you want to bond this to. I have 4 physical NICs in this server, so you can choose which one you want your traffic to exit out of. If you did not configure the native VLAN on your physical switch, you can set that VLAN to be tagged right here. This is going to be for that management network. So in this case, I was talking about VLAN 10. I'm going to do VLAN, not 140, VLAN 10, and that will now let my host tag each frame as it exits the NIC with VLAN 10. When it enters the switch, it'll see VLAN 10 and broadcast it out to the other management ports, which would be VLAN 10. As you can see, I've already got an external switch configured, so I'm not going to go ahead with this configuration. I'm going to click cancel. But if I were to click apply, you're going to see a warning pop up that says, hey, this is going to have an impact on your networking. If you haven't configured your switch correctly, you will lose all access to network access to this machine because it is wiping out the configuration on your NIC to build that virtual NIC and then reconfigure it. So even if you do configure it correctly, if you have everything set up perfectly, you'll still lose network connectivity for about 5 seconds. So that is what is going on. And let me show you what that actually looks like once it's done. Let me bring up ncpa.control panel. So I bonded mine to data 1. And if I go to properties, you can see I did have a static IP at one point on data 1. Now there's nothing. There's just a checkbox for LLDP. That's good. And the Hyper-V extensible virtual switch. That means this is just going to be linked to that virtual switch. And it's just acting as that go-between. This is the NIC that it creates. vEthernet, parentheses, and then the name of the virtual switch that you created. My virtual switch was called external data. When I go to properties again, you can see all the configuration is there, and that's where I set my static IP, DNS configuration, and everything like that. These other guys, you don't have to worry about that. We'll talk about that when we get to high availability in Hyper-V, and centralized storage and failover clustering and all that stuff. But right now, we're just talking about how to get the data going. Okay, so there's that. So now that we've got communication from the host to the physical network, we've got VLAN tagging set up on the switch. We can actually go into, our VMs here. And before we go forward, I'm just going to remove this so you can kind of see what the process looks like. I'm going to add hardware. This is a Generation 2 Hyper-V VM, so we don't have things like legacy adapters anymore. We just have good network adapters. I'm going to click Add. Which virtual switch do you want to connect this to? Well, if I created an internal or private virtual switch, they'd be there. I've got external data. That's what I want. And if I were ready to tag this traffic, all I'd have to do is check this box, wipe it out, and put in 50. And then all of a sudden, this VM is going to send all its frames into the network, tagged with VLAN 50, and the switch will take it from there. So like I said, this configuration, look, there was nothing to it. There was just create the virtual switch, give it a name, bond it to a port, and if you need to tag it, tag it. Then come into your VMs, add a NIC if you haven't already, choose which switch you're going to plug it into, and then tag its VLAN. That's it. So the planning is much more important and needs to be done up front, because remember, when you make changes, it does disrupt your network connectivity on that host. So you want to do all of that planning and design. You want to bust out that whiteboard and draw it up first before you actually dive in and just start doing things. But once you get it up and running, it just works really well. So, hope you like this stuff. Hope you enjoyed watching this video as much as I enjoyed making it. Get out there and try it for yourself.